All right. Thank you guys. Sorry, I bailed on the first time I was going to present this. I was in the ER the night before, so everything's good. So, um, but yeah, so this is just an update of the 2022 Water Resources Report. We spent 3 hours at the Riley Purgatory Summit with which includes cities, DNR, county, um, just talking about this presentation and a couple others. So I'm not going to do a full 3 hours for you guys, but I condensed condensed it down,
Please.
removed a few, yeah, removed a few slides. So I'll just get to it here. So basically what I'm going to do is I'm going to cover I have it split into the Purgatory Creek and then the Riley and Bluff Creek sections. And then basically I'm just going to roll through these agenda items. So I'm going to first talk about the creek water quality summary, then talk about the lake water quality summary, go over some alum results and what we're seeing, what we're thinking about doing, talk about carp monitoring results, go over some of the vegetation monitoring. I'm not going to go over all of it. Um, and then just some miscellaneous updates and stuff like that. So first I'm going to talk about the Riley Creek watershed. This is, well, what you guys are going to hear a lot of this year and what you know already is it was a very dry year this year. This is actually the wetland that drains into Lake Susan, which is one of the issues we're looking at because it's a huge loader to Lake Susan. So that's just what this picture is. So what the district does is we go out and survey creeks at each one of these monitoring locations, the B5, B4, those circles. We go out bi-weekly and we collect a whole bunch of water quality data and SON profile data and turbidity and a whole bunch of information. And then to kind of wrap it all up at the end of the year into this nice figure, we summarize what we found. So uh, uh, each type of impairment, so total suspended solids is the top one. If it's listed next to the stream segment, that's why it was impaired. So each one of these streams had 11 impairments. Um, Total phosphorus was the most, the impairment that was triggered the most across the district, but specifically within the Riley and the Bluff Creek. Um, just as a general trend, as we drop into the lower Minnesota River Valley, you can kind of see it goes from, so blue is we didn't have any impairments, and then green is 1, 2 is red, 3 or more is black. So as we drop into the Minnesota River Valley, you can kind of grade steepen. We have more sandstone substrate, so it's easily erodible, and we kind of get this degraded water quality just as a general trend. So one thing I will talk or will say is I did not include the dissolved oxygen impairment unless it had been triggered in previous years. The fact is Bluff Creek all the way down to B2 and Riley Creek all the way down to R1 were dry at some point or stagnant at some point this year, which is pretty crazy. And we have not seen that since I've been here. We might have seen it, I guess, uh, in the district prior to when I started. But as you guys know, it was kind of a crazy year in general. So this is just a general update. We have a creek restoration action strategy. Jeff Weiss is very familiar with this project. He was actually, we jointly, the district and Jeff, when he worked at VAR, kind of created this monitoring program. So basically what we do is we go out, we monitor each stream. We try to do it on a 3-year cycle. We haven't been we haven't quite done it every 3 years. So what we'll do is we'll pick a stream or a section of the stream. We'll walk it. Every reach in the district of stream has been walked and assessed by the CRAS. And now we're in the updating section of it. So kind of just going from top to bottom on Bluff Creek. These are actually organized. The scores on the right are organized with the sections that we walked, and it's just kind of highlighting the sections that we walked that are circled. So I'm not going to go into too much detail, but I'm just going to generally stream segments improved, but that's not always the case. So B5, that's currently, if you guys aren't familiar with, we're looking at a stream restoration project on B5C, which still improved slightly, but it's still, and the improvement was based on some of the scoring methodology. We're a little hard on it the first time going through, I think, but it's still in need of restoration. It didn't get out of the black category or the severe category. One of the sections that B2B on the tributary arm of Bluff Creek there, the next circle down, we did actually have scores deteriorate a little bit in that section, just increased scarps or erosion along outer banks or outer reaches. B2 scores actually improved, just the whole reach scores improved. BT3A, if you can see that, the score went from 22 to 10. That's one of our restoration sites. And so this is the first time we actually scored it after a restoration. And so we went from, the severe, and I would argue that this was one of the worst sites in the district as far as stream loading, just stream degradation. So we actually improved it to a, less than 12 score, which is very good for a stream section via the CRAS. So that's one of the things we did this year is we went to almost all of our restoration sites and scored them to give an update on kind of what are we seeing? Does it, did we improve it? And this section specifically very much improved. So
CRAS means creek
yep.
restoration.
Yep. The CRAS means Creek Restoration Action Strategy. Yep. If you guys have any questions along the way, you can just kind of shout them out. I do go to the acronyms a lot, or I will gloss over something if you want me to talk about something a little bit more detail. So yeah, this is just a scoring methodology. The tier 1 scores are what we're looking at specifically within this assessment. And those are kind of the measurable. So the stream habitat assessment, which looks at habitat in the stream, the modified Fan-Cook stream stability rating, which is kind of an erosion metric, infrastructure risk. So if there's any kind of, creek crossing that's deteriorating or someone's house is about to fall in, that would be captured under that infrastructure risk. And then water quality is the other impact or the other variable that we're assessing. So now onto the Riley Creek. You guys may be familiar with the Upper Riley project is what it's called. This is a large section between Highway 5 and Lake Susan. It's right in development stages of a creek restoration. City of Chanhassen is a partner. So I just wanted to highlight here that the stream actually did degrade since the first time we walked through. And this may be from the Park Road culvert restoration. This is just a hypothesis, but they redid the culvert there, and that might have caused some head cutting upstream from that. That culvert was essentially buried or pretty much, halfway buried. So when you remove all that sediment, the stream a lot of times will cut upstream. And so that's why I think partially an explanation of why this is degraded. I mean, it was degraded to begin with as well, so it just deteriorated more after that. So R2E is also one of that's the other creek restoration that we did. That's the Lower Riley. You might be familiar with that name. City of Eden Prairie was a partner with that. So again, we went from that extremely high score down to the fair score, just borderline fair, good section. That reach, you guys may have seen, I should have put a picture of it, but that was the picture of that house that was getting encroached on. and huge bluffs eroded away. Eden Prairie lost a trail. So that between Bluff Creek tributary and the Lower Riley, those were kind of the two worst stream sections in the district based on the CRAS. Based on if anyone were to go walk all of our stream reaches, you would come to that conclusion as well. So, and then, oh yeah, we did walk the Lower Riley reach, so R1. We wanted to, that's uh, um, the Frederick Miller Spring location. So I just wanted to update on the scores. I believe the managers requested that. So as you can see, R1A, that's upstream of the site, actually improved. R1B improved slightly, but R1C did degrade a little. It didn't move categories, so it's still in the poor category, but there were some increased erosion. That specific hillside collapse that people are most familiar with, it's visible right off of the row or the site, the Frederick Miller Spring site, and then the bridge kind of collapsed. A lot of times that's what we see with these huge, massive scarps is the stream will actually try and correct itself. It'll eat away into the bluff and then cause a collapse. And the upper vegetation on that bluff that's collapsed into this stream can actually stabilize that section. Not to say that there isn't an issue, but that's kind of what we saw with that site. Now, moving downstream, we did see some increased scarps or, erosion areas. So I just wanted to give you guys a quick update on that. So now going into lakes water quality. So for the Riley chain of lakes, it was nearly identical to 2021. Most lakes comfortably met the MPCA standards. So Lucy Ann, Rice Marsh, Riley, they're a nice blue color. That means they met every standards that the MPCA looks at. So the three main standards, not every standard. So that includes chlorophyll A or algae, total phosphorus, and water clarity. Lake Susan did not meet any of the standards. Previously, it did meet the SECI standard, but it did not meet any of the standards this year. I'll talk a little bit more about the data in the next slide. And then Riley continues to have the best water quality in the district. This is post-alum treatment. So again, kind of that historical water clarity we have not seen before since data was collected. So greater than 4 meters of water clarity post-alum treatment. And then just as a note, all the lakes met the chloride standard. I'm going to talk a little bit more about that here in a slide. I know there's some interest in that. So this is just the summer growing season average. So that's from June to the end of September, so October 1st. We go out, the district goes out every other week. We collect all this data, it's clumped together, and this is how the MPCA will kind of judge the lake at the end of the year compared to the standards. So I didn't include the SECI. Lake Susan was the only one that didn't meet it, and it was just above the standard. But each lake, or so the top graph is total phosphorus. The lakes are listed on the bottom. And then you can see the different standards for shallow lakes and deep lakes. So again, kind of what I talked about, all the lakes met and were fairly well under the standard. Lake Susan didn't meet it. And then on the bottom there is chlorophyll with each one of the lakes. Again, each one of the lakes met it well within the, except for Lake Susan. One thing we don't have our results back, but phytoplankton results. So last year we had a huge spike in cyanobacteria blooms. That's the harmful algal bloom that can produce toxins. We had levels in Susan that we had not seen previously. We have data going back to the 1990s in Lake Susan. It's very, very high cyanobacteria, and I would, just based upon the chlorophyll levels that we see there, I would most likely guess that our phytoplankton numbers would be higher this year as well. We're looking at getting them results back. I should check with the lab that we send. We should get them pretty quick. So, and I know there is, yep, go ahead.
Josh, John Tyler, did you by chance include Mitchell Lake in your testing?
Yep, I'm just going through Riley chain and then I'll go into Purgatory Lakes
Okay, all right, thanks.
next. Yep.
Yep.
So I know there's some interested in salt and chloride levels. I know it was talked about at one of the board meetings. Marilyn, you might have brought it up too as well. So this is plotted all the chloride averages. Actually, it's every single chloride point that we've collected. We started in 2013 and we've been collecting data since then. One of the things I should make everyone aware of is we started collecting summer chloride levels every month. Winter, previously we only collected winter chloride, which as you can expect, you would see higher chloride levels in the winter due to road salt and application and stuff like that. We don't do all the lakes in the wintertime. We rotate between the lakes. So we'll do the Purgatory Creek chain of lakes for 3 years, and then we'll switch to the Riley chain of lakes for 3 years. And this is collecting more than just chloride data, but chloride is kind of the big one that we're looking at specifically in the winter. So as you can, this is actually an average of the upper chloride and the bottom level chloride. So as you can see, Rice Marsh Lake is the only lake that approaches the standard, which is 230 milligrams per liter average chloride concentration. But one thing you will notice is there is a slight incline on at least Riley, Rice Marsh, and Susan towards this most recent 2021 and 2022. So that's interesting, and this is one of the reasons why we're continuing to monitor chloride. Obviously, it's an issue. So I'm going to talk a little bit about alum. So the next couple of slides are going to be about alum.
Josh,
Yep.
before you go to that, you had mentioned that maybe the salt was, or the chloride was affecting the plankton. Are you tracking that now?
So chloride can affect, everything in the lake. It is below the MPCA standard, which I have highlighted that's the red dotted line going across the top. So it is below the standard. It can have impacts on macroinvertebrates or zooplankton, phytoplankton. That's one of the reasons we track phytoplankton and zooplankton. Also, they're the base of the food web. So when things start changing in those populations, all your upper predators from bluegills on up, it's kind of this chain reaction type of an impact. So
say, Josh, didn't you talk about blue-green algae?
Yep.
And it was phosphorus. Is phosphorus the worst actor there? Is it known to be the the bad actor for that?
So cyanobacteria is it's a chlorophyll measure of cyanobacteria and phytoplankton algae type of, that's more of a measurement. Total phosphorus is why most lakes, especially in the metro area, but even you could probably apply that to Minnesota. It's the limiting nutrient in lakes. So what does that mean? It means you can add a bunch of other stuff to a lake, but when you add just a little bit of phosphorus, you can see drastic changes in a lake. So drastic deterioration. That's kind of the limiting nutrient that drives a lot of that. So you could say that total phosphorus drives high chlorophyll concentrations even. So
Thanks.
So for those of you that aren't familiar with alum is basically a byproduct of water treatment plants. We apply it to the deeper sections of the lake, And what it does is cap the phosphorus. So once you could completely control, so say Lake Riley, for example, if we were able to control all the external sources, so that's stormwater ponds draining in, all this hard surface draining into the lake. If you could shut off Riley Creek draining in on the one end, if you could completely control all them sources today, right now, we just control them all. We still have this internal loading of the lake. So that's all this historical loading. So pre-settlement, agriculture that was around Lake Riley prior to development, and then all the development. So all this phosphorus that's accumulated over the years can actually be re-released via internal loading when the lake stratifies and oxygen isn't available in the bottom of the lake. So this is during the summer period. So that phosphorus can be re-released into the water column, and we can see these huge blooms and stuff, even though we've controlled all these external sources, which isn't possible. I should highlight that as well, to control all the external sources. So this is why we apply alum to a lake and basically cap that external or that internal loading that keeps on happening. Usually these are applied with 2 doses. That's evident by the horizontal bars in the graphs. And these will be the next series of graphs that I'll show. So as you guys can see, this epilimnetic, so that's top. So it's on the top. The top graph is the top. So that's samples that were grabbed from the top, and then the hypolimnetic is the bottom. So that's samples that were grabbed from the bottom. So one thing you'll note is surface, the scales of the y-axis here. So that's the phosphorus milligrams per liter are very different, because phosphorus is always higher on the bottom because phosphorus is settling always. So so on the top there, you can see that red line, which is the MPCA water quality standard for deep lakes, which is 0.04 milligrams per liter. So prior to the alum treatment, you can kind of see this very high values. Summertime, I even have the highest value there in 2013 covered. And then the first dose happens, you can see values, most of the values are below the MPCA water quality standard. And then the second dose, where we moved around some of our application to really capture all this internal loading going on, we really had reductions. And that's kind of generally what we see. Looking at the bottom graph, you can kind of see between the 2 doses, there's this stair step kind of right back up. And that's how we know the second dose needs to be applied as well. And that's why we move these in 2 doses. I'll talk a little bit more about this too. Oop. So this is Rice Marsh Lake. This is a little bit of an experiment because shallow lakes and the type of phosphorus that are in Rice Marsh Lake are different than what we see in deeper lakes with firmer bottoms. If anyone's been to Rice Marsh Lake, it's kind of a marsh, it's mucky bottoms. But so far it's been successful. It's looking like the second dose will be applied in 2024. And this is one of the things where I talked about splitting up doses. So that orange value, or the orange graphic there, the orange color, is our original treatment zone. And again, we're targeting the deeper areas because everything kind of settles into the deeper area. The red area is what we're looking at potentially. This will be up to the board of managers of how we proceed, but those green dots in the middle of the lake, those indicate our sediment coring sites. So what we do is we'll go out, we'll grab sediment cores, and then we can see how much release is from those sediment cores. And it kind of gives us a picture of how much phosphorus is actually being released. When we went back out after our, between the 2 doses, we've consistently measured these 3 locations, and the site 4 actually had an increase, or that's outside of our treatment zone, had a fairly high sediment release rate, while the treated zones were very low. So this is one of the things, again, why we split our 2 doses, so we can really nail down what needs to be treated, how we can maybe we can take some of the treatment and shift it over, or we could treat the whole thing, and that's just a cost, and this is what the board of managers will be looking at as we move forward with the second dose application. Dave, did you have a question or?
Yeah,
Yeah.
just really briefly, when you say alum caps it, it doesn't actually chemically react with the phosphorus. Does it create sort of a physical barrier to over the top of it? That's what you mean by cap?
So it's not actually a physical barrier. It is more of a chemical reaction, but it's a binding efficiency. So basically what happens is the phosphorus binds to the particulate of the alum, the aluminum sulfate. And so when it's bound in this form, it's not able to be released. So a lot of the phosphorus in Lake Riley was iron bound phosphorus. And so that's a really weak bond. So when the lake stratifies in the summer, when it gets real hot and there's a thermocline,
Yeah.
all the water below that is doesn't have oxygen. And once oxygen isn't present, that bond breaks apart. Whereas the aluminum sulfate bond
Yeah.
actually is really tight and holds on to this phosphorus.
So I had it backwards. It is chemically binding it.
Yeah, it's
So
we're not,
complicated, and you don't
yeah,
have to you don't have to go through all of it.
it is,
That's-
it's a little more complex, but yeah, that's a
That's
very
fine. That's fine.
brief.
Thanks.
Yep. So now I'm just going to talk about what we did, specifically looking at the AIS monitoring that we did in, and I know this includes all of it, but specifically looking at the Riley chain. So we did adult zebra mussels monitoring all the lakes but Rice Marsh. Zooplankton and phytoplankton monitoring occurred on Susan, Rice Marsh, and Riley. And then point intercept vegetation surveys. So that's the gridded surveys that we conduct every 3 years that lets us see what vegetation is like in each lake. That's every 3 years. It occurs every 3 years on most lakes. Some of the lakes have more with a lot of the bigger projects. So for instance, Lake Riley, we just had the alum treatment. We would expect an increase in plants, species, stuff like that. So we need to monitor and make sure that includes an increase in curly leaf pondweed and Eurasian water milfoil. They can also react to this increased clarity. Some of the lakes are monitored a little bit more frequently. So we did point intercept vegetation surveys on Lucy, Susan, Rice Marsh, and Riley. And then as far as treatments went, curly-leaf pondweed was treated on Lake Susan. And then Lake Riley, we had curly-leaf pondweed and Eurasian water milfoil treated. And then this is kind of the end of, we've been collecting, thanks to all of our volunteers, I know some of the CAC members are volunteers. So this is adopt a dock plates. So you can take a plate, we'll provide a plate, you put it at the end of your dock. And at the end of the year, we actually count the zebra mussels that we find on the plates. And so this is kind of tracking the general population. It's a very rough and dirty estimation. I will put that out there. But since 2018, where we average 4 mussels per plate, we went to 600 mussels per plate. And again, this is kind of what we see in perfect zebra mussel lakes, which is what Lake Riley is. We see these increases, these nice curves, and then crash, increases and crash. And that's basically zebra mussels eating themselves out of home, basically. So they're consuming a lot of the phytoplankton and stuff like that. And then they crash. And some of the lakes you can get a crash for a couple of years. And other lakes like Lake Riley, where it's perfect conditions, we see these really sharp crashes, or that's what we're seeing so far. Again, we're going to kind of keep tracking this population just to kind of see how it goes. Lake Riley is the first lake in the district that has been infested with zebra mussels. And I'll talk about Lotus, the other lake where we is listed in the next section here. So now to talk about carp. So the district goes out, we do electrofishing to assess the adults in the lakes. And then we'll do small mesh trap nets to see if basically this YOY, that's young of year carp. So to see if any baby making's going on, that's lets us know. Right now we're on a rotation in the Riley chain of lakes. We'll do adult electrofishing 1 year on each lake. We'll do adult electrofishing 1 year. We'll do trap netting 1 year, and then we'll skip a year. So adult, we didn't actually capture any carp on Lake Lucy this year. With we did a couple did get away, but this is all part of this basically biomass estimate that we have. So we did trap netting on Lake Ann. We didn't capture any young of the year carp, and then the adult carp biomass level in Lake Susan Park Pond. So this is the pond that's upstream of Lake Susan. It was 165 kilograms per hectare. The base threshold from where carp start to cause problems is that 100 kilograms per hectare. So we're above the threshold. We've been above it for a couple of years. I'll show a graph at the end here too that will highlight that. Just saying there's a lot of carp in this pond. Again, it's probably an overestimate because it is a pond, so carp are more easily captured in the pond, but we're taking a look at it. We did put a temporary barrier in front of Lake Susan Park Pond this year because last year we did see some recruitment, so some baby making happened, and we wanted to prevent that. We didn't see any young of the year this year, so that's good. Hopefully that continues. So now just to talk about some of the vegetation management that we've been doing, the district has been looking at. So the top graph, and this will give you guys a snapshot too, when we're doing these point intercept surveys and looking at our delineation surveys for treatment. This will kind of give you guys a snapshot of what we're doing. So the top graph here is the Lake Riley curly leaf pondweed frequency of occurrence from 2011 to 2022. And then each individual kind of section that are barred off by the black bars on top shows what kind of treatment happened and then what we're seeing just as a general trend. So the y-axis is frequency of occurrence. So that means how robust the population is when we're doing our point intercept surveys. So this generally, you can kind of see curly-leaf pondweed just hangs out at that 20 to 30% when we treat, and when we don't treat, it steadily increases. And this will only increase with the improved water clarity that we saw post-alum treatments. So, and then the bottom graph here shows the Lake Riley Eurasian water milfoil frequency of occurrence and the treatments that we've done. And these are the different surveys. So May surveys, June surveys, and August. So it kind of gives you a really full picture of the vegetation, how it's responding. So one thing to note is that 2017 treatment was really effective, but also dinged our natives. We've been kind of working on using some of these lesser or honing in on our treatment and how we treat and the different type of herbicides that we use to make sure that this doesn't happen again. And it was really effective at removing Eurasian water milfoil, but we also did see a reduction in our native plants, which we don't want to see. And so since that treatment, Eurasian water milfoil has been under control fairly well. And this year, it's likely we won't treat, but if you were at the last board meeting, that was one of the lakes that we are proposing to treat because we can't go back. We can only, ask for approval now so that we can treat if needed. And that's kind of that proposal that you probably saw at the board meeting if you were there. So. And this is just I wanted to highlight here so on the two graphs on the what would be your left. So these, can you guys see my pointer? I'm not sure if you guys can see my pointer. Maybe not. Oh, you guys can see it? Okay. So this is actually the point intercept data that I was talking about. The lake's gridded out. And this is the 2011 and then 2021. I didn't put the 2022 data on the right here. And this just shows all the management that's happened. So from carp management to aquatic invasive species management, plants, shows the impact of what management can actually do. We have, this is all, so the top graphs, the comparison is all the vegetation. So just comparing 2011 to 2021, you can see a drastic increase in the vegetation, just out deeper as well. So with greater water clarity, you can actually see water, plants expand out deeper. And then on the bottom here, this is actually the number of species found at each point. So you can see we've actually expanded the number of species at each point. So this is what we're trying to achieve on most lakes, or on all lakes, is a robust population of plants that is, you know, multiple species per plant or per point that we find. And then on the bottom, if you see native species, this is actually the number that we've had. We've kind of been stagnant at this at this 8-9 species. We were hoping we'd get a bump up with the improved water clarity. And then this is some of the stuff we're working with the DNR, talking about doing plant in lake vegetation transplants to try and get some of these other native plants to grow. So this is the Lake Susan graph. Again, top is curly leaf pondweed frequency. Again, we're kind of sitting at this 25 to 30% treatment. And then native plants are actually on the bottom. And one of the things to highlight in Lake Susan, we generally have a very low number of species present in the lake. I guess frequency of occurrence, so the amount of plants and how they occur in the lake. We actually have 11 species that were found in the 2022 survey, which if you looked at Lake Riley, which was 9, so we have more species, but there's just not as many of them, and that is limited with light. The limiting factor there is Secchi disc, or light penetration to the bottom, and that's why we have a lot of projects going on in Lake Susan. And then I'll talk about the Purgatory Creek restoration. Just a quick explanation of the pictures here. The pike, well, that was our biggest pike this year, was 39.5 inches. It was caught in the Purgatory Creek Rec area. So that's upstream of Starring Lake. This middle picture here is Zach teaching at the Starring Lake Outdoor Center. The rake picture is a curleaf delineation survey. This is actually one of the bottom picture here of the lake level sensor. That's our lake level sensor reading dirt for a section of the year. Round Lake specifically is highly affected by surface water runoffs. It's such a small watershed. So it was very dry compared to the other lakes. And then this is actually a picture of Silver Lake and the wild rice. They've had some water level fluctuations in the past, and the lower water levels have actually expanded the wild rice population on Silver Lake pretty drastically. So that's pretty cool, and one of the unique things about the district and one of the lakes in the district. So again, this is just looking at Purgatory Creek. This is that impairment status. Generally, Purgatory Creek has been better, specifically upstream, than Riley and Bluff Creek. Again, as you drop into the Minnesota River Valley, we do have more impairments. And then looking at lake water quality. So again, the next 2 slides, I'll kind of talk about this. So Silver, Duck, Round, Idlewild, and Highland met all the MPCA water quality standards. Highland Lake previously had not met and was actually one of the worst water quality in the district when I started here at the district. But with cooperation with Three Rivers Park District, we did apply alum. And the second dose was applied by Three Rivers Park District this last year. And so we've actually achieved all the water quality standards, the main ones. They're dealing with some curly leaf pondweed response to the alum treatments. But overall, the water quality is drastically different than specifically when I started at the district. Starring Lake increased pretty dramatically in total phosphorus and chlorophyll. I'll kind of get into why that happened here in a little bit. And then both Red Rock and Mitchell met the TP standard, which they previously didn't meet in 2021. And they actually had reductions in chlorophyll as well. Lotus Lake did not meet the TP standard last year, and it did meet it this year. And chlorophyll levels kind of stayed the same and are slightly elevated. And then again, here's that just a summary of the mean average growing season. We have total phosphorus on the top. You can see Starring Lake drastically above. And then, but all other lakes met. And then chlorophyll here on the bottom was not met by Lotus, barely above the standard for Mitchell, and we did see pretty good improvements in Red Rock. Starring Lake, you can see the values are way higher. So one of the reasons, or the reason why we saw such elevated total phosphorus and chlorophyll values in Starring Lake is twofold. One, we had extremely low water levels, as you guys know. But the second one is we did a whole lake fluoridone treatment this year, which is a herbicide. And that was meant to address some of the impacts we saw for Eurasian water milfoil. It was getting essentially out of control. I'll show you graphs here in a little bit just about that situation, but it was getting out of control. We needed to treat it, and this fluoridone is kind of a reset of the lake. We didn't have hardly any other species of plants in the lake. It was Eurasian water milfoil and coontail, and that was pretty much it. And so nothing was able to grow. Well, when we removed that kind of biomass of plants, you get this, combined with the low water levels, you get this increased mixing. So basically the water was being mixed by the wind and causing resuspension of sediment, and with that was phosphorus. So this is probably a reason why we saw that this year. And as native plants, hopefully native plants, expand, we should see a reduction back to what we were seeing prior to the treatments. And I have a couple more slides about that. Just going into the chloride levels again, you guys saw these graphs previously, average chloride concentrations, every point that we've collected since. You'll notice that Idlewild is above. Idlewild technically isn't a lake, it's a high value wetland, but we've been continually monitoring it. It gets a lot of runoff from Highway 5, 212. It gets a lot of runoff. And so it actually is above the standard most winters. All other lakes besides Starring, which is the lowest lake on the chain in Purgatory Creek, you know, all other lakes are kind of pretty well below the chloride standard. I just wanted to point out, so you can see on the scale here, this red line here, this is the 230. That's the MPCA water quality standard. Well, we've been measuring some stormwater ponds that drain Eden Prairie City Center. We do this every year just as just to take a look at the chloride levels. One thing to notice is the max value on the lakes is 400. The max value over here is 14,000. So these are stormwater ponds that are meant to capture a lot of this chloride, but obviously during high water events, it is flushing through the system. We have noticed that a lot of chloride does stay in the stormwater ponds, which is what stormwater ponds are designed to capture nutrients and stuff like that. But again, some of this is making its way down into Purgatory Creek. And I just wanted to show that as a kind of side note that some of these locations that receive extremely high salt concentrations, obviously, you know, the mall gets a lot of salt to prevent slips and falls and stuff like that. So we're talking 12,000, you know, milligrams per liter salt concentrations. We have seen a reduction since we've been monitoring. But again, this is influenced by winters and the amount of salt that needs to be applied that winter and stuff like that. It's got variables like that. Hopefully,
Josh, is there any other significant source of chloride besides road salt?
yeah. So certain fertilizers have salt concentrations in it, and water softeners also have and can be a factor with salt. But the main, the main, those are all little tiny bars when you compare it to salt application in the winter. So,
Right. Thanks.
all right. So again, this is looking at alum. This is the round lake concentrations. So this is the total phosphorus concentration. Top graph is the top water sample grabs. The bottom is lower bottom samples. And this was completed by Eden Prairie with some district funds. So they did 2 doses, and then we've still seen maintained water quality, total phosphorus levels below the standard average, a couple of points above, but it has been pretty good. And then this is Lotus. So Lotus Lake received its first dose. We didn't quite see the impacts that we saw on Riley, but Lotus is a very long, deep lake. It has a lot of, you know, deeper water, and it's long and skinny. And we're currently looking at how to apply the second dose to capture some of that untreated area of the lake, and how we can better manipulate the treatment to reduce some of these phosphorus levels. We have seen very significant reductions just overall, but you know, not quite the Riley example is kind of the example that we're hoping for. Now, every lake is different. Alum applied in each lake is different as well. So this is kind of what we're leaning towards. Currently, Bar is putting together a memo about what we're going to be considering. So the 2 areas that are highlighted are the treatment areas that were treated. So these are the deep water areas, and we saw really good results. Each one of these little points, again, is one of our coring locations. It's 40, 50, 20, 30, 10. Theirs are highlighted in this graph over here. So in sites, so this is the white bars are 2017 release rates, and then the gray bars are the 2020 results. And so you can see that within the treatment area, the site 30 and site 50, drastic changes in phosphorus release rates. When you look at,
Josh,
yep,
could you
yep,
please raise your screen? Thank you. Yeah, thank
yep,
you.
sorry. So outside of the treatment area, though, we're seeing these fairly high, this near above 4 milligrams per meter squared per day is what we're looking at, is trying to get below. That's pretty high for. So again, we're going to look at maybe moving some of this alum around, potentially increasing some of the areas that weren't treated. So maybe treat some of these deeper areas, go along the 15-foot contour. That's kind of what it's leaning towards right now. Here's a picture of kind of the results they've seen in Highland Lake. Again, they've suppressed this is just the top phosphorus. Second dose was this last year. So looking at, again, I won't go through everything here, but we did a lot of adult zebra mussel monitoring on all lakes. Yeah, on all lakes within the district, within the purgatory chain. Zooplankton and phytoplankton is collected on lotus and starring. Point intercepts occurred on lotus, round, Mitchell, starring, and highland. And then invasive plants were treated: curleaf pondweed on highland, Eurasian water milfoil on starring, curlyleaf and red rock, curleaf on red rock, Mitchell, and then Eurasian water milfoil on lotus. Do you have a
Does-
question? Yep.
Is Duck Lake connected at the surface to the purgatory, or is it all underground?
It's connected by culvert,
Culvert.
so
Thanks.
most is underground, I guess. So, and then just talking a little bit about lotus, what we've seen here so far. So eDNA, since lotus was listed in 2018, we've done, Carver County has done eDNA sampling on 3 sites previously. And so far it's tested positive every year but this year. So this was our first negative test. So eDNA is, you take a water sample, send it off, a lab analyzes it. It's very sensitive. And that's one of the issues with it, is sometimes it can be too sensitive. But previously we had gotten positive results every single year, at least from one of our sites, a lot of times 2. This year they only did 1 site and it was negative. Villager sampling we've done, that's basically baby zebra mussels. They're microscopic, you can't see them with the naked eye. We did that twice this year. We've done it twice since. We found no villagers in the lake. We have adopt-a-dock volunteers, only 5 plates this year, previously 10 plates in the past. We've actually not found a live zebra mussel in the lake since the lake was listed in 2018. The intensive shoreline survey, so since it was listed, the district has went out and we actually do physical scans inside the lake, very intensive, looking at hard structure, looking at very zebra mussel friendly areas, and we're scanning intensively. We usually do that in the summer when it's nice out and we can go and really look at it stuff. We also do it in the fall because that's when everyone's boat lifts are up on shore, docks are up on shore. So as part of the initial listing, the DNR listed lotus. 1, Carver County found villagers at the access, public access. They did a tow right at the access. They found villagers. 2, we got eDNA hits, and 3, we found a dock and lift with desiccated zebra mussels on it. So this year when we did our intensive survey, we've kind of had this, besides eDNA, we haven't found anything since it was listed in 2018. Well, district staff went out this year in the fall and we found a lift with literally thousands and thousands, tens of thousands of zebra mussels. It's hard to see, but all these dots you are seeing on here are zebra mussels, and then there are some larger ones as well. Just based upon all the other surveying we've done, all the other intensive surveys we did, finding nothing else, we think this dock was brought in, set on shore by a lake service provider, brought down from the resident. But again, I know that Lotus Lake has been interested in delisting it, and the DNR really isn't opposed to delisting it. And they would be willing to start the discussion, but this kind of sets us back in that discussion, because when we find stuff like this, it makes us nervous, and it makes the DNR nervous about delisting a lake that would have zebra mussels. So
Is there any lake that's been proven to get rid of zebra mussels once infested in
No.
Minnesota?
No, currently there has been no lake that has achieved like zebra mussels come in, they treat it. They have not, no lake has ever been delisted, and no lake that's been infested with zebra mussels has recovered. So, but
Yeah.
again, all the signs pointed to you know, up to this point, even to this point, this dock and lift, all the mussels were very desiccated, very dried out. They were dead. But again, it sets us back to potentially delist the lake when we find stuff like this. So I just wanted to point that out. So I have a kind of summary slide here after this about carp, but we didn't see any young of the year carp in Lotus Lake. We didn't see any, I'm just looking at my time here. The upper Purgatory Creek Rec area, which historically we've had high carp biomass numbers. We're below that 100 kilograms per hectare threshold. No young of the year were captured, which has been consistent. Lower Purgatory Creek, we actually captured 4 young of the year carp. This is very low levels compared to what was previously seen before carp management, so not much of a concern. And then Starring Lake, we were well below the 100 kilograms per hectare. This Starring Lake Purgatory Creek system, this is our problem child when it comes to carp management. So we've been monitoring this lake, this system, the wetlands and Starring Lake a little bit more intensively than say the Riley chain of lakes. Then this next slide. So the top graph, I've been talking about carp biomass. The 100 kilograms per hectare is that threshold at which carp start causing issues. And I put all the lakes that we monitored this year and what their kind of status is. So this really high abundance up here, this is Starring Lake. You can kind of track it all the way through. And now we're below the threshold again. Upper Purgatory Creek, these are just snapshots. It's not the full survey, these beginning points, but we had some really high levels of carp and now we're below the threshold as well. Lake Susan Park Pond, like I talked about, this is the triangles here. We're going down, but we're still above the threshold. Again, this is a pond. It's probably an overestimate as well. But again, it seems like a lot of the fish in the Riley chain of lakes are shifting into this pond to try and reproduce. And before this, we didn't see any actual reproduction occurring, but last year we did see some reproduction. So we put that temporary barrier in place and that kind of led us to, it looks like it worked this year. So we'll see moving forward. Then this bottom chart here is just the removals we've done since 2018. That's removals at the Starring Lake and Purgatory Creek upper the rec area, basically. Those are the removals that we've done. Those are kind of the more intensive spring removals that we've done in previous years. And they will be running soon. So, and then I wanted to highlight some of the goldfish. I know every time a goldfish story comes up, we get lots of calls about stormwater ponds and goldfish, which is good. We want to know where these goldfish populations are. It's still kind of unknown. There's not a whole lot of research on what goldfish can do to a lake, what level of goldfish will cause problems in a lake. They're essentially a mini carp. They're in the same family, but it's known that it's less detrimental to have goldfish in a lake than a lot of carp. So, but still it is a concern. It's not supposed to be there. So this is one of the reports we got on Kerber Pond, which actually drains to Lotus Lake. So the district went out, we looked at the goldfish and we did our actual removal event that was very successful. It took us about 4 hours and we basically corralled the goldfish into one point and surrounded them with a big seine and then basically electrofished inside of the net. And we were able to remove 23,310 goldfish in about 4 hours. So would they cause a problem if they reached Lotus Lake? There's a lot of predators in Lotus Lake that would be real happy to snack on some goldfish, but just the sheer number of goldfish in Kerber Pond warranted a removal event in Kerber Pond. So We did do a smaller removal event in another stormwater pond in Chanhassen. Wasn't nearly as successful, but we did get a few out, so. Scroll through. Starring Lake. Well, I'll talk about this. This is a lot of numbers here. A lot going on in these graphs. But basically, Highland Lake, Three Rivers Park District treated a fluoridone treatment that's similar to what we did. It was the same as what we did on Starring Lake. It's a whole lake treatment because all they were seeing was curly leaf. And so they treated it. It was very successful, but this is kind of one of the unique things they saw is this bottom graph here is turion. So that's the little seed that curly leaf uses to reproduce. They treated it and they still had this extremely high level of turions. So turions can survive herbicide treatments, especially in soft sediment lakes, because they're essentially buried in the sediment. So a herbicide can't actually impact them. And what they were seeing is actually growth at the end of the year, which is not common in curly leaf. Curly leaf grows under the ice and then dies off, under the ice and grows to about June and then dies off in August. And so you can kind of see this nutrient shot to your lake in August that can cause algae problems. They actually saw growth in August and September, which is very interesting and kind of a unique situations. So that's all I'll say about that without getting too far into it. Starring lake vegetation management. So I kind of wanted to show this. This is actually pre-carp. So this is the frequency of occurrence. So how often plants occurred. And this is native vegetation on the top. So I just wanted to kind of show you guys how the plant community responded and kind of what we've been actively managing. So pre-carp removal, there essentially wasn't any plants because the carp density, if you guys saw in the previous figure, 500 kilograms per hectare, a huge carp population, just wiping out the vegetation. Then we start getting a little bit of carp control and we get this good response, the native plant community. Then if you guys look, you can kind of line up these graphs here from top to bottom. This is actually curly leaf and Eurasian water milfoil. So you can kind of see even curly leaf wasn't doing very good when carp was in. Then we did this endothol treatment because the curly leaf pondweed was about, you could about walk across the lake and it was so abundant and dense. We needed to do something. So we treated with endothol and then we got really good control of curly leaf, even to this, to currently, we just with that one treatment, we got really good control for a large number of years to this date. So one thing you'll notice is we did have a little bit of reduction in plants. That's probably expected, but still we were able to maintain a pretty healthy plant community. So now moving up, if you guys compare again, this is Eurasian water milfoil in this gray bars here. So we did a treatment, this whole lake fluoridone treatment, because Eurasian water milfoil was so rapidly expanding since it was found. We needed to do something. And this is actually the post-fluoridone valley down here. So near 0% after this treatment. And the native plants actually that we found were still kind of maintain this higher level. So we're hoping that the native plants expand and we get some of these other native plants that we know are in Starring Lake to show up in our surveys. So, and one note is we didn't actually, this was pre-fluoridone treatment, this curly leaf, and fluoridone will impact curly leaf as well. So this is likely lower the curly leaf bar down here. So I think this is my last slide. All right, I'm coming up to my full hour. So so this is actually a graph I just wanted to show everyone. So this is based on the point intercept surveys. So that's kind of the intensive surveys gridded out the lake. We go to each point, we throw a rake, or and then we see what's all on there and how dense it is. So this is all the lakes in the district, and this is the number of plants. The yellow bar, the yellow at the tip of each bar is the invasive plants that are in each lake. And then the gray bar is the number of species in each lake. So as you can tell, Lake Ann is our rock star plant lake, right? It's got 28 species of plants, 25 native plants. In Highland Lake, Round Lake, they're kind of smaller lakes, smaller watersheds. They have less plants. So most of our lakes are hanging out in this 10 to 15 plants. And so I just want to kind of show you guys what we're looking at as far as whole picture, what we've been seeing as far as aquatic plants, the number of native plants in each lake. So, and then just to kind of wrap it up, this bottom picture is Turion. That's a picture of a Turion. It's almost like if you're searching around in the mud, which is what we're looking for, you kind of bump into it. I compare it to a pine cone. You kind of run into it. It's really hard and structured. This is us collecting sediment cores and just doing some winter sampling. Here's an angry turtle, snapping turtle from our nets. There's Eleanor holding some carp on Starring Lake. This is the Children's Water Festival that the district went and did an AIS education event. So, and I guess with that, I'm sure you guys each have lots of questions. I know every year I do this, I just cram a whole bunch of information, but I try and get as much out and kind of the bigger picture stuff that as I can. Obviously I could spend each lake, I could probably do a presentation and each creek and each different, even, type of work we're doing on each lake even. So, but I hope you guys find this informative. If you guys have any questions, I could answer them now. I know I'm pushing you guys up against your time limit, but
Hey, lots of information, Josh.
yep, lots of information.
Just in 2 sentences, can you tell us overall, are things getting better or not?
It's a hard to lump all the different types of monitoring that we do into one category.
Right, it's a really tough
Yeah,
question, but you know, what's your gut feel?
It's kind of tough for me to to answer that question as a general, kind of question, I guess.
So Josh, are we evolving? I mean, sometimes it's lessons learned and then you make things better, but.
Yeah, so the district is very much we call it an adaptive management strategy. So a lot of times what happens is you pull one lever and something happens. Something you weren't expecting to happen happens. And then you try and solve that problem by pulling another lever and something else. And so you have to be adaptive in your management. So, for instance, Lake Riley, we did the carp management. We got some of these external sources under control. We've gotten the AIS, the vegetation, the curleaf and Eurasian water milfoil under control. We did the alum treatment. We're continuing to monitor the AIS to make sure that doesn't get out of control, including carp. And we had this really successful, water quality, overall picture of the lake improved. Starring Lake, you could kind of say the same thing, but we had that little bump in reduction in water quality because of the fluoride treatment and the low water levels. Overall, I'd still say Starring is much better than what it was. Well, it is much better than what it was pre-carp, management. Our creek restorations have, just based on the CRAS, the scores have been really good with the CRAS. And those were some of our most degraded stream sites that we did. So it's kind of a loaded question. I feel like I can't just say as a broad general statement, oh yeah, we're better. I guess I would say in general, lakes have improved since I've personally been at the district overall as a blanket statement, but again, there's all the levels in between there, so
Yeah, that was a tough question and
yeah.
putting you on the spot, but there's so much information, it's hard for us to interpret
Yeah,
the
yeah,
big picture too.
one thing I didn't put on there, the water resources report is available if you want to go to a specific lake and look at some of the work that's being done. That might be a source for you. Also, if you guys ever have any questions, I am available to answer questions. So yeah, we have the lake fact sheets. The updated lake fact sheets are also available. Liz might have already showed you guys at least an example of one of them, but we do have them available. So that specifically gets into each lake or each creek. We have creeks covered under that too. So Marilyn, or Dave, do you have any more questions or?
No, I just want to thank you for the
Yep.
big effort there. Thanks a lot.
Marilyn,
Yeah, my question was about street sweeping. I know Eden Prairie at least sweeps pretty much like once a year, and it's way after the heavy rains fall. So all the sodium chloride, and I gotta imagine the phosphorus and the total
Yep.
suspended solids are all winding up in lakes. Can we influence the city to sweep more often? Also, it seemed like there was a project in Chanhassen where they were buying a street sweeper, was it?
Yep. So
And has that shown to be an improvement for those lakes or?
yeah, so I know a lot of other watershed districts have done kind of they've had a more robust street sweeping program installed, and they did a little bit more monitoring work, and they actually showed how much phosphorus can actually this is specifically looking at phosphorus, but how much phosphorus they've been able to keep out of the lakes and the streams. And it was pretty drastic, I will say. And I know specifically Eden Prairie, I've taught, or at the summit was looking at maybe they were looking at something involving, increasing or, running more, something like that. They were at least looking at that because some of this kind of new research that come out was showing, pretty dramatic reductions in total phosphorus. And they're an MS4, so they're looking at trying to prove that they're capturing, the nutrients before they get into our lakes and streams, and having that to show that they're complying with their MS4 permitting through the state. So I know there is definitely a push to get more street sweeping going across the metro area. I know specifically, but I know specifically Lori Hawk did say something about it and was talking about maybe looking at it. So, and the district did basically assist Chanhassen. We put funds in for the purchase of a street sweeper. And I believe that is their only street sweeper that they have. Don't quote me on that, but I think that is their only street sweeper. So.
Okay, I thought there was something very high tech about it, but I couldn't remember what it was.
I
But,
think Lori had mentioned in the summit how the extreme difference between the cost of prevention and the cost of the
Yep.
fix.
Yep.
That they were definitely looking at street sweeping, saying, hey, if we can keep it out, it's a lot cheaper in the long run, even though it's expensive.
okay,
So
yeah.
not chasing
A
the
lot
good
of the
money.
nonprofits that I support, like they'll send us sample letters saying, please send these to your representatives. I wondered if the watershed district was interested in doing some of that, because, I would be very happy to send to the, Mayor on case and stuff, but it'd be a lot easier if it were more factual and knowledgeable coming from the district, and then to me, and then I would send it to them. I know you might not want to. Anyway, just a thought that not just street sweeping, but other best management practices that, we could be a source of, just reminding the city that, we'd like to see this done. So.
Thank you. Perry, did you have a question still? I thought I saw your hand up. You're muted.
Nope, you're on mute, Terry. Terry, you're on mute. There you
Oh,
go.
yeah,
Yeah.
yeah. Thanks, Josh. I looked at the report because I kind of like that stuff. And Eleanor showed the link. So anybody wants to get more info, like Josh mentioned. And I was surprised, even with the drought, there was a lot of improvement in areas.
Yep.
And maybe Mother Nature needs that anyway. And so look at the report if you got the, if you got the gumption to do it.
Yeah. Terry actually assisted the district in some of the carp monitoring work. So he was out there electrofishing, so slinging carp around. So
yeah, anytime I can get out and see fish.
All right. Any other questions before we let Josh go? Thank you, Josh. We always appreciate your
Thank you
presentations.
so
They're
much.
always informative and raise a lot of questions. And we're all going to go to bed tonight thinking, I should have asked them this.
but like I said, if you guys have any questions, just let me know.
Oh, here we have a question.
Yeah, we've adopted the drain out in front of our house, and a bunch of the HOA people jumped on board right away, but didn't follow through with it. So now we're going to adopt the drains down the street. And regarding Eden Prairie and the street sweeper, it might not be a bad idea to try to get some literature out there or some kind of information out to Eden Prairie on how easy it is to adopt a drain and, sweep up, weigh it, and report it to Hamlin University.
Yeah, I don't want to. Eleanor might have a little bit more information about that, but I believe she might be promoting that, at least. I know at the very least. So
Yeah, we always have literature out about it when we do tabling events. City of Chanhassen right now is actually doing an Adopt a Drain challenge. So Lake Riley, Lotus Lake, and Lake Minnewaska right now for the next 2 weeks are battling to see who can adopt the most drains. I don't know, it is
Just to let you know, I believe Lake Lotus has received the early lead.
early lead. It is, adopting the drain versus, actually committing to clean it is always another roadblock there. But it's good to be getting that information out there, and it's something we're exploring with doing some different lake associations or different schools getting out and adopting drains and having like classroom battles. So yeah, it's one of my favorite programs that we're a part of.
Yeah, obviously we can't sweep the entire street or the neighborhood. That'll become a full-time job, but every little bit helps.
Yeah.
So thanks a lot for the presentation. We're having some serious internet troubles here, so we're going to have to sign off. Things are getting really glitchy and flashing around
and unstable. We keep being popped out, and we're losing.
Yep.
Voices are chopped up. So
Or you can just black it out and see whether or not we can maintain some of that bandwidth. So
yeah,
thank you though. Thank you for your attendance, and hang in when you can. And if you get off, we know why.
Okay.
Thank you very much.
All right. Well, moving on then, Josh, thanks again.